You know, data is absolutely everywhere. It's shaping our world in ways we don't even see. But how do we actually make sense of it all? Well, today we're going to pull back the curtain on the secret language of data and really demystify the basic ideas of statistics. Just think about it for a second. When you hear a news report mention the average income or the average price of a house, what does that one number really tell you? And maybe more importantly, what could it be hiding? That's exactly what we're going to dig into. All right, so here's our game plan. We're going to start with the absolute basics, figure out what statistics even is, then look at the different types of data. From there, we'll see how to turn numbers into pictures and get into the really core ideas of finding the center and the spread. And then we'll wrap it all up with why this stuff is so important for you to know. Okay, first things first, let's get a handle on what statistics actually is. And listen, forget the scary formulas you might be picturing. Just think of it as a powerful toolkit for understanding the world around us. So, at its heart, statistics is a science, but really, it's a process. It's not just about the final number you see in a headline. It's about the entire journey the data takes, from where you get it to how you analyze it, and finally, how you figure out what it all means. Let's break that down into 4 simple steps. It's a journey, right? First, you've got to collect the data. Then, you have to present it in a way that actually makes sense. After that, you analyze it to hunt for patterns. And finally, this is the most important part. You interpret it. You tell the story of what the data is saying. Now, this whole field really splits into 2 big branches. On one side, you have descriptive statistics. This is all about summarizing the data you've got right in front of you, like, say, finding the average height of students in one specific classroom. And that's going to be our focus today. The other branch, inferential statistics, is when you take that classroom data and try to make an educated guess about the height of all students, everywhere. So to work with data, we first need to understand what it's made of. It's kind of like learning the alphabet before you can read. We've got to learn the basic vocabulary. At the very top, pretty much all data falls into 2 main buckets. You've got qualitative data, which is all about qualities and categories, things like eye color or your gender. And then there's quantitative data, which is all about numbers you can actually measure, like your heights or how many calls you made yesterday. A simple way to think about it is one describes what kind, the other describes how much. And we can get even more specific. Inside those categories, you have nominal variables. These are just labels with no real order, like marital status. Then you have ordinal variables, which do have a natural order to them, like a first, second, or third place finish. On the number side, discrete variables are whole numbers you can count, like the number of cars in a lot. And continuous variables can be any value at all within a range, like the exact length of a phone call. Okay, so we've got our data, we know what kind it is. Now for the fun part, making it easy to understand. This is where we stop looking at boring spreadsheets and start turning those numbers into pictures that tell a story. And this quote right here just nails it. A good graph can tell you more in 2 seconds than a giant table of numbers could tell you in 2 hours. It's all about making the data easy to digest for everyone. I mean, just look at this pie chart. This shows it perfectly. You don't need to read a long report. You can see in a single glance that potato chips and tortilla chips are the absolute kings of Super Bowl snacks. They're dominating over half the pie. That right there is the power of a good visual. All right, now we're getting to the real heart of descriptive statistics. We've got our data, we've made a picture of it, but how do we boil it all down? How do we find its center? Because that's the whole challenge, isn't it? If you have thousands of pieces of information, you can't talk about every single one. You need one number, a single value that can kind of represent the whole group. But which number do you pick? This brings us to the 3 big ways to measure the center. First, you've got the mean. That's the classic average we all learned in school. Then there's the median, which is the value that's literally smack dab in the middle of the list. And finally, the mode, which is just the one that shows up the most often. Now here's the key. They each tell a different story. The mean is great when your data is nice and tidy, but if you have a few really extreme values, we call them outliers, the median often gives you a much more honest picture. So finding the center is a huge first step, but it's only half the story. To really get what's going on, you also have to know how spread out or how clustered together all the data is. Let me give you an example. Imagine 2 basketball teams. The average height of the players on both teams is exactly 6'7". They sound similar, right? But on one team, almost every player is right around 6'7". On the other team, you have a couple of 7-foot-plus giants and a few 6-foot guards. See? Same average, but they are totally different teams. That difference, that's the spread. So the question becomes, how do we put a number on that idea of scatter? How can we actually measure if the data points are all huddled together or if they're spread all over the place? The answer is this really powerful idea called standard deviation. Now, don't get intimidated by the name. Forget the formula. Just think of it like this. It's a single number that tells you the typical distance of any data point from the average. That's it. A small standard deviation means everything is consistent and clustered together. A big one means there's a ton of variation. Okay, we've covered a lot of ground here, from what statistics is, to the types of data, to finding its center and spread. So let's bring it all home. Let's talk about why any of this actually matters to you. So if you take anything away today, let it be this. First, statistics is just the language we use to talk about data. Second, pictures like charts make that language way easier to understand. Third, and this is so important, a number like the average is pretty much meaningless if you don't also know the spread. Put them all together, and these tools are how we turn useless information into actual knowledge. And this, right here, is the real superpower. When you get these basics, it changes how you see everything. You're no longer just passively accepting the data you see. You're now equipped to look at a headline and ask those critical questions like, okay, which average are they using? And how spread out is that data really? Is there something big they're not telling me? So I'll just leave you with this one thought. The next time you see a statistic, in an ad, in the news, anywhere, what's going to be the first question you ask to find out what's really going on?